Hello everyone. So today I am going to discuss a small problem in decision tree. Okay, this is one question from this course Introduction to Machine Learning by NPTEL. Okay, this is a question from the week 6 assignment. So here the question is entropy of a 50-50 split between two classes is what. Okay, so this is particular question from the topic decision tree. Okay, so here in case of decision tree, what we do, okay, for a decision tree we will be given a data set, okay, something like this. So this is a very popular data set that we use in machine learning community for understanding the basic algorithms like decision tree or naive Bayes. Okay, so here this decision tree, so this data set we have some samples or examples for 14 number of days, day 1, day 2, day 3 up to day 14, and we are having different types of attributes or features, we call it, right? Outlook, that then temperature, humidity, wind, and there is this final target feature or the class level of that particular data set is given. Okay, so here how we design or how we develop that particular decision tree for this particular data set, what we do is we calculate some information gain value or some entropy value or some Gini index value for each and every attribute, okay, for each and every features, and then finally we have to end up in deciding what will be the class level, okay, for a particular flow, okay, for a particular attribute. Maybe if the outlook, suppose this is one attribute, if the outlook value is sunny, right? So when the outlook is sunny and then depending on other attribute, temperature or humidity and wind, what a particular person will do, okay, play tennis, this is the decision that we have to take. The decision of playing tennis will be yes or no. Okay, that is what my decision tree will give me. So what we do generally, we calculate something called entropy. Okay, so what is entropy? Entropy for a given collection S, okay, and S is the data set. So this data set will have like ideally some positive and negative examples of target concept. That means the target feature value, okay, feature value is either having positive values or negative values. So that means, in other words, the class labels are either yes or no, or sometimes we also denote it as 1 or 0. So this is a two class problem ideally we are considering. Now for this two class problem we need to calculate something called entropy. Okay, entropy, what will be the entropy? So entropy is what? Entropy, if we go with the definition of entropy, entropy is degree of randomness, right? Degree of randomness. So we have also a mathematical formula to identify, to tell the degree of randomness. Okay, that is what? Minus p divided upon p plus n multiplied by log p by p plus n on base 2. This base is 2 because I am considering for my data set the target feature value are either positive or negative. So there are two types of class levels. Okay, based on it my this base will be 2, and then that logarithm value also I will calculate on all the positive out of the total number of samples. Okay, minus again n by p plus n, log of n by p plus n. So this S, this is a sample of training example, which in other words we call it as a data set. Then p is the proportion of positive examples and n is the proportion of the negative example, or in other sense we can understand that p is the count of all the positive sample and n is the count of all the negative sample. And this is how we calculate that entropy value for that data set. By knowing the p and n value, I can calculate that entropy value. Okay, what is again p and n? P will be the count of all the positive examples or positive samples whose class level is positive, and n will be the count of all those samples whose class level will be negative. Okay, so if we come back to our data set, okay, then here the class label is this tennis, and these class labels are either no or yes. Okay, so now I have to find out what? I have to find out the p and n value, the count of positive sample and the count of negative sample. So what is the count of positive? 1, 2, 3, 4, 5, 6, 7, 8, 9. So count of positive value is 9. Count of negative value is 1, 2, 3, 4, 5. Yes, count of negative value is 5. So once I am having this p and n value, I can substitute these value in the formula of entropy, and we can calculate the entropy value, which is 0.94. Okay, now once we calculate this entropy, further we will also try to calculate entropy values and the information gain value. Actually, finally I have to find out the information gain value for this particular attribute, right? Or if we follow the card example, card algorithm, then we have to find out the Gini index. But before finding all this, we also have to find out the entropy of the data set. Okay, so the entropy of the data set having 9 positive and 5 negative samples is 0.94. Okay, so this is the entropy value that we have got from these data set. Okay, now if we go back to our question, it is asking entropy for a 50-50 split between two classes. Okay, so we have to understand the question first. It is asking that there are two classes. Okay, that means what? In that formula of entropy, my base will be 2. Okay, this is the formula of entropy. In that formula of entropy, my base value will be 2. Why? Because whatever data set they have given, it is having 2 classes. But then they are also giving more information that it is a 50-50 split. Okay, so what is a 50-50 split? As we again go back to our example, you can see here whether it was a 50-50 split in this particular example, whether it was a 50-50 split. No, the 50-50 split meaning is that I must be having 50 samples in the positive side. Okay, for the out of those 2 classes, whatever is the number of samples, 50% of it should be positive and other 50% should be negative. Okay, that is what this question is asking. So for this particular example that I have considered, here I am having total how many samples? 9 plus 5, that is 14 number of sample, and out of which 9 is positive. So percentage of positive sample is this one. Yes, percentage of positive sample is this one, whereas percentage of negative sample is this one. Okay, but for this particular question, 50% will be in the positive class and 50% will be in the negative class. Okay, so as we have here below you can see more number of examples I have taken. Here when the previous example from from this data set, okay, from this data set 9 was positive, 9 was positive count and 5 was negative count, so final entropy was this one, correct. Then I am having the second example where you see I am having 8 number of positive sample as well as 8 number of negative sample. So this is some random data set only I have considered, and here you can see that the split, as it is asked in the question, the split is 50-50, correct, because 50% is in the positive class and 50% samples are having negative class. Okay, so for such kind of example my final entropy value is what? 1. Okay, so this is 8 by 16 positive, 8 by 16 log, and 8 by 16 negative, and 8 by 16 log of that negative. Yes, so that's why the answer here is 1. Now we can also the same formula only, okay, if I don't know exactly the total number of samples, okay, but I know that 50% is positive, 50% is negative, I can also substitute the entropy values, the entropy for that particular data set as what? My p by p plus n it is, right, p plus n, and then log of base 2 p by p plus n, okay. So second, and then negative symbol again, n by p plus n log of base 2, okay, log of n by p plus n. So here the number of positive count is whatever it is, suppose it is x, then number of negative count will also be x, okay, because total should be twice x, and any p or any n, it should give me what? X will go, then it is half, which is nothing but my 50%, right. So half multiplied by 100%, it is 50%. So same thing I can substitute here as well. Minus x is a positive number of sample, x positive number, again x negative number, because number of sample positive and negative should be same, so that total will be, if we consider as 100, either p or either n will be 50%. Okay, so log of again x by twice x, right, minus x by twice x log of base 2 x by twice x. Okay, so this we can give in bracket which will be minus half log of half, minus half log of half, correct. So which will turn out to be 1. If we do this calculation, it will turn out to be 1. Here as well, 8 divided by 16, which will be half, right, 8 divided by 16 will be half. So this if we put in a calculator, the final value will be 1. Okay, that is how the answer for this 50-50 split will be 1. However, one more important question you can note that if all the samples are positive, okay, 8 positive and 0 negative, whatever given in the data set, out of the two classes positive and negative, all the samples are positive and 0 samples are negative. So in that case, what is the value? 8 divided by 8 by 8 plus 0 log of 8 by 8, and this rest all number, this will be 0, correct, this will be 0, because 0 is multiplication with the entire term, and this which will turn out to be this 8 by 8, this is 1, and log of 1, log of 1 is what? Log of 1 is 0, so minus 0 it was, right, which will give me 1 multiplied by again 0 will be 0. So if the count of any of the positive or the negative samples are 0, then it will give me 0. Okay, the fourth example you can see, all the positive samples, what is the count? 0, and negative sample count is something, okay, it is 8 suppose. So this will also give me entropy 0. Okay, So here from the definition of entropy, if we go back, the definition of entropy, if we see, what was it? Degree of randomness. Okay, so if in my data set all the samples are either positive or all the samples are either negative, okay, that means my data set is very monotonous. I don't have much of the randomness in my data set. Okay, all are positive either, all are negative. So that's why my entropy value, the degree of randomness is 0. But if in my data set or half of the samples are positive and other half is negative, so my degree of randomness will be the highest, right? That's why that is 1. I hope it is clear. Thank you.